In my previous video I had some questions about the small CNC I built, the mostly printed CNC, and I wanted to share some thoughts about both the construction of my CNC and the comparison between the two machines, because some of the viewers had the question which CNC to build first, if at all, and which is, I guess, better in some way. So let's start. This is my first machine I built from the V1 Engineering, the mostly printed CNC. I built this some 9 months ago, maybe more, and since that I have had a quite interesting experience with it. This is my first CNC per se. Previously I had some experience with 3D printers. I have this Tivo Tarantula that I modified quite heavily. Couldn't say if I improved it, but it's definitely not the same machine I bought it, but yeah. So I had some experience with the code and electronics and stepper drivers and all sorts of things. But this was my first CNC for cutting things, and there were many new things I learned by building this machine. The cutting area is 400 by 400 millimeters. The Z height is somewhere between 8 centimeters, but it also depends from the spoil board height, and I usually tend to put some plywood sheets on top of it just to preserve the spoil board. So it varies, but I believe it was somewhere around 8 centimeters. The tubing I used is aluminum extruded tubes. These were quite expensive, and it's hard to tell if these are better than these metal tubes. These are for drawer hangers, you know, where you hang your coats, and these are for, I don't know really, but these are aluminum and those are metal. Both are quite sturdy, but these are quite much more expensive. If I had found the metal tubes before, I would definitely choose the metal ones for this project. The router is Makita, one of the cheapest small routers I could find. It's somewhere around 300 watts of power, but it's definitely underpowered for this machine, because to get some results I have to crank the spindle speed quite high, and it leads to all sorts of problems like burning and you know, the end mill burning, and then the material burning, and not good stuff. So I'm planning to replace it for a DC spindle from the usual suspects on eBay, but at the moment I have to work what I got. This is the speed control. It's just an ordinary, if you type in eBay, motor speed control thingy. You can see it here inside is the module. It's nothing too fancy. It was somewhere about around €5 or something. The screen, the SD card reader, as you have on printers. This is the motor driver box. I'm using the MKS board with the standard drivers for this machine. Power supply, some protection, and the emergency stop button. Nothing too fancy here. The dust cover is made from a see-through plastic I don't know how to call it even. I know on eBay it's sold as a tablecloth see-through, but it's like food wrapping foil, you know that one, but just a bit thicker. It's 0.2 or 0.3 millimeters in thickness. I had these as cutoffs for at my job, at my workplace. We use these to make rain covers for lighting fixtures. Yeah, and that's about it about mechanical part. These are the small NEMA stepper motors. I believe the nominal amperage for them was 2 amps, but I'm running them at 1 amp because of the small motor drivers. So a bit underdriven, but the torque is plenty. I'm cutting somewhere between 10 to 20 millimeters per second at depth of probably 2 millimeters max. Plywood sheets. Wood, I can push it a bit more, but nothing much faster than that, so somewhere between 2 and 3 millimeters and up to 20 millimeters per second the speed. I'm planning to use this machine in future mainly for aluminum cutting, to cut some aluminum parts and aluminum name tags and custom panels, something like that. But to do that I have to do something with the spindle, because at the moment it's to cut without losing RPMs. I have to push the speed, but when I push the speed there are moments when there is some chip welding on the end mill, so that's not ideal. These are some failed results from before. This was one of the first attempts. You can see clearly it's like friction welded. So not ideal. This is a bit better. Here I'm using compressed air to push the chips out of the way, but on these two examples the G code bugged out on me. I don't really know why, maybe the memory card's faulty or something. But I had some better results as well. All in all, this machine cost me between 300 and 400 euros to make. And the main part where I spared some money where I shouldn't have was the spindle, because not the spindle, the router, because it cost somewhere between, I believe it was 50 to 60 euros. It's really cheap, but in the future I will upgrade it. But all in all, for around 300 euros you get quite a powerful computer controlled router. I had some previous ideas to make this machine a bit smaller and without the base, where you can basically just put the machine on top of the part you want to machine, to cut some name on it or engrave it or something, like portable engraver, but in the end I decided not to do that and build this machine instead. But maybe in the future I will modify it or build something new. But which is better, the mostly printed CNC or the Lowrider? Well, it depends. By comparing the bed sizes, the Lowrider is definitely a bigger machine. You can build it up to full plywood sheet size. But the mostly printed machine, if you build it so big, then there would be some problems with the tube strengths and overall strength of the construction. I believe the size I have is roughly optimal for this size machine, because I can't imagine that I would have such sturdiness of the frame if it would be bigger. And for the Lowrider, I had the cutting dimensions 1.5 meters by roughly 1 meter in x-axis, and I believe this also is the biggest sheet I could cut with this one, because of the well, I have some structural problems with this as well, and I can't imagine building this machine much bigger, because there are other designs and other ways, and truthfully more expensive ways to build it bigger, but I believe this is also the maximum. But yeah, if you are cutting big things, big sheets, something over 0.5 meter by any dimension, then I guess the Lowrider is better choice for you, just because of the dimensions. And I should mention also the Z height is comparable, if not greater, for the Lowrider than for the mostly printed CNC, but I guess it also depends how you design it. So I would not say that any of these machines are better with dealing with the workpiece height. They are essentially in the same league. The Lowrider is definitely more expensive, just because of the material amount you need for each machine. I forgot exact number on this machine, but it was somewhere 2 times the cost of the Lowrider. But it also depends on the spindle you use, on the tubing you use, on the 3D material you use, and also motor controllers. And well, you could buy the cheapest parts and you could build the Lowrider CNC to match the cost of the mostly printed CNC, and vice versa. And but all in all, the mostly printed CNC will come out a bit cheaper than the Lowrider. So the sturdiness of the frames, I guess the Lowrider CNC loses in this department because of the size of the cutting plane, because it's on the rollers. You can see that you can move it about, it wobbles a bit, and you know, it's not that sturdy. Of course the motors are not energized now, but even when they are, you get some flex in these parts, and also some flex on the tubing. Of course I try to minimize it in this design, but there's still some backlash noticeable. One thing I could try is to use either a thicker plywood or maybe use some metal parts, but it would add weight and strain the motors more, so there's a balance to be found between the sturdiness and the backlash you get. The mostly printed CNC is much more sturdy. It forms a solid frame, and only wobbly thing I guess is the Z-mount, but also if it's assembled correctly and with the care, then the backlash on that part is minimal. It's overall more sturdy machine, I would say, because of the frame, and well, also it depends how big you build it. The sturdiness is the main reason, because is the main reason why I chose this machine to be my aluminum engraving and cutting machine for the moment. The cutting speeds depend on the spindle, of course, and the sturdiness. At the moment, although this machine is more sturdy, the spindle is a bit underpowered, so I'm getting more speed out from this machine, where I use the proper variable frequency driven spindle. This was 1.5 kV motor. The spindle makes great difference. Versatility, well, I guess you could use both the Lowrider and the mostly printed CNC as vinyl cutters and 3D printers, but more versatile platform, I would say, is the mostly printed CNC. But if you want to straightforward only cut things and not do anything else on these machines, then I would say the Lowrider is the better choice, because of the possible bed size and part size is bigger. Of course, I have mounted laser on this machine, which gives it more versatility when compared with my mostly printed CNC, but I guess as a platform the MPCNC is more versatile. Ease of assembly, well, I would say they both are easy to assemble if you follow the instructions on V1 Engineering webpage. I wouldn't say that there are some difficulties, because the design itself is quite good, and there shouldn't be any problems. Whether you choose the big or small CNC. It also is true for the parts used. Both machines use readily available hardware and tubing, and there is no specific parts needed for the machines. Well, only one specific component is the spacer between the wheels bearings. I came to a solution where I just printed the spacers and it works as well. The spacers are needed so that the wheel spins freely. Otherwise, the more you tighten this nut, the more the wheel is braked, and it strains the Y motors. Reliability of these machines is strongly dependent from both the accuracy and I would say craftsmanship and quality of your work, as well as the component quality you choose. You can build this and be sure that it's reliable all the time. Everything works, every connection is good, and the code doesn't fault out. But you could also not tighten the bolts, get some parts loose, get some parts to break, make some connections that are bad, when encounter all sorts of problems. The main thing is to be accurate when you build these machines, and try to avoid as many mistakes as you can, because if you have a part or some kind of assembly or something, if you cut some complicated design which takes better part of 5 to 10 hours or more, then it's extremely annoying if some motor connection fails or some other connection is bad, or you suddenly lose a belt or something and you have to redo it again, and it costs you material and time, and yeah, well, you have to do everything you can to avoid this in future. Yeah, customizability also depends on the builder itself. You can stick to the design and build it as Ryan had intended these machines, or you can modify them any way you want. All the parts are available for modification, and if you know your CAD software well enough and want to experiment with other design solutions, well, this is the perfect example for that, because I had made some modifications on this machine and everything still works as previously. This also is true for this machine, but this is pretty much stock. Only thing I not changed, but rather added, was this connection box, which is, I guess, not needed. But I wanted to have the ability to change out the router without changing the wire loom, and well, yeah, there were all sorts of solutions that I chose to make the motor change more easy. These are connected with the Molex connectors. I had a rant about these connectors in my previous video, but on this machine I have changed them plenty of times that they finally work reliably. But yeah, you can do all sorts of modifications. You could enlarge the contact surface of these bolts to avoid 3D printed part splitting, and you could change the tubing shape if you like. You could make this for square tube or V-shaped profile, or you can do quite a lot of things, but as is, you could also leave it stock. So each machine has its benefits and downsides. Each machine can be built for specific task, and well, I believe that's the main advantage of these machines, because they are so customizable, and you could do with these whatever you want. For me, for my workshop, I guess the Lowrider CNC is the best choice, just because of the sheer bed size and the parts I can cut on this machine are more useful for the work I do. But for others, I guess you could also do with the smaller, mostly printed CNC. You have to understand that these are hobby machines, and they are not meant to be your main money makers or the basis of your company or something, because these are, in the end, these are tubes stuck together with some plastic, and if you put some serious workload on them, you will find that the time you spend cutting on these machines is more valuable than the few dollars you save when not buying some more bigger machine. But also it depends on the work you do, because maybe I don't know, maybe you assemble some mechanisms where you need some CNC cut parts, and you want them as fast as possible. Then these machines serve great for rapid prototyping and something like that. But there are nowhere near as capable or sturdy or reliable or in essence fast than the more serious commercial CNC machines. The main thing I got out from these machines is that I got to learn about the electronic parts, the programming part of these machines. I got to build it myself and see how things go together, and I improved my craftsman skills, and I had generally a great time building these machines, which is also quite valuable if you look at it from certain angles. And if you manage to squeeze some dollars out of these machines, then the better for you. But when it comes to situations where you want to put these machines to work as your main income source, then I highly doubt the possibility of that, because in the end the more expensive machines would outperform you and cost less in operation and drive the margins down enough that these machines would not just be good enough. As for me, I fall into the camp where I need these machines for rapid prototyping and experiments with all sorts of things, because I tend to have some ideas where a helping hand that works on zeros and ones could come in handy, and also the precision that I get from out from these machines is much higher than the precision I would get if I cut the parts by myself, and all sorts of things. These are just handy tools to have, you would say.